Welcome. This video is CCBYNC. Glad to have you back. Chapter 3 is sort of the beginning of this whole idea of proving identities. And what we're going to be using as we do this are our list of rules that we've learned so far. There's more to this list, actually, as we go further and further into it. But for right now, what we're trying to do is make the left-hand side turn into the right-hand side. Meaning I can't assume that this is already equal. I'm trying to prove that it's equal. A very common trick that I like to use is break everything into terms of sine and cosine. And sometimes stuff will cancel out. Sometimes it'll make a clear direction on where you're supposed to go with that. For this first one, I'm going to start with the left-hand side. Every time I saw LHS, I went to Lakewood High School in California. So it's my alma mater there. CSC, cosecant of theta, so CSC of theta, tangent theta. What I'm going to do is I'm going to rewrite both of these in terms of sine and cosine. Now, cosecant is the reciprocal of sine, and tangent is sine over cosine. So this becomes 1 over sine theta tangent becomes sine theta over cosine theta. And you can see sine thetas reduce. I'm left with 1 over cosine theta, which by definition is secant of theta. Look at that. We achieved it. Example 2, prove the identity. Now, I'm going to use, do you see 1 plus cotangent is cosecant squared? So this right here, this here is cosecant squared x. I'm also going to use this one here. I know that this is just kind of side work. Sine squared x plus cosine squared x equals 1. What I can do is I can subtract a cosine squared x to both sides. This tells me that sine squared x is equal to 1 minus cosine squared x. And why is that relevant? Well, that's because this here is now sine squared x. So let's start this. Left-hand side, we start with 1 minus cosine squared x, 1 plus cotangent squared x. And we just showed that this is now sine squared x times cosecant squared x. And I'm going to do my trick again where I want to break it up into sine and cosine. And I know cosecant is 1 over sine. So this becomes sine squared x times 1 over sine squared x. We can now see the sine squared x's reduce out. We're left with 1. There it is. For this next one, we want to keep in mind that another trick, if everything already is in terms of sine and cosine, which it is here, what we can do is, if we have a fraction, is we can get a common denominator. And that's exactly what I'm going to have to do in this case. So once again, the left-hand side, I have sine theta over 1 plus cosine theta plus 1 plus cosine theta over sine theta. And I'm going to note that the LCD, the common denominator, the LCD in this case, is sine theta times 1 plus space sine theta times 1 plus cosine theta. So I somehow need to turn these two denominators into that. Well, what's missing here, this on this left side here, is sine of theta. And on this one, we need a 1 plus cosine theta. That's 1 plus cosine theta. And going to give us, up top I have sine times sine, that's sine squared. Theta, you can see these are getting a little complicated, plus 1 plus cosine theta squared over our common denominator. And I'm gonna recall for this here, a rule. It's called a perfect square. A in this case is the 1, B in this case is the cosine theta. So I have sine squared theta plus 1 squared, which is plus 2 times 1 times cosine theta, so 2 cosine theta plus cosine squared theta. And I'm going to note that I see sine squared theta plus cosine squared theta. And those become 1. To be clear, sine squared theta plus cosine squared theta, and I just put the 1 in front. 1 plus 1, of course, is 2. This one's a little longer than the others. Up top, I'm now going to factor a 2 out. And once again, I'm going to notice 1 plus cosine theta reduces out. And I'm left with 2, and I'm going to write it like this, times 1 over sine of theta. And we know 1 over sine of theta is cosecant theta. There we are. All right, we have a couple more to go. You'll note a calculator does not help with these at all. All right, so for this next one, once again, I'm going to take the left-hand side. And by the way, the approach that I'm taking for this, another teacher or tutor may have a completely different approach and end up with this doing it perfectly correctly. So there's more than one way to do these. I'm going to stick with the theme of breaking everything into terms of sine and cosine. And we know that tangent is sine over cosine and cotangent is cosine over sine. And I have a complex fraction here. So what I'm going to do is I'm going to multiply the top and bottom by the common denominator, which is sine cosine. And that is going to turn into and here when I multiply, the cosines cancel and I'm left with a sine squared. Right, cosine cancels and I'm left with sine times sine. So there's my sine squared. Down below, something similar would happen. I get sine of theta, cosine theta, plus, and here again, the sines reduce out. I'm left with cosine times cosine, which is cosine squared theta. Now up top, I'm going to notice I can factor a sine of theta out. And I'm left with cosine theta plus sine theta. And down below, I have a cosine that I can factor out. And I'm left with sine theta plus cosine theta. And cosine theta plus sine theta is the same as sine theta plus cosine theta. So very nicely, this entire portion cancels out, or reduces is a better way of saying that. Leaving me with sine of theta over cosine of theta, which as we know is the tangent of theta, which is our and one more. All right, so this one's worded a little bit differently. It will end up being the exact same thing. So we have to start with the left-hand side. We don't have a right-hand side, and we're looking for some function that's going to be squared after we're all done with all of this. So let's rewrite it. Secant t minus cosine t over secant t. And sticking with the theme, you may notice you could break it up into two separate fractions, and that would work itself out as well. I'm going to rewrite the secants as 1 over cosine. And I'm now going to multiply the top and bottom by cosine t, the LCD in this case. And you can see cosine t times 1 over cosine t, that just turns into a 1. Cosine t times cosine t is cosine squared t. Down below, cosine t times 1 over cosine t is just 1. And as we showed earlier, one minus cosine squared x is sine squared x. Or t in this case. So when they're looking for f of t now, and f of t is squared, what's function is being squared here? Well, the function f of t is now sine of t. These take practice. There's no easy way to get good at them. You just have to do as many of them as you can. Don't get too discouraged. You'll pick up on some of the tricks as it goes.